All right, y'all. Today we're talking about food chains and food webs. And for food chains and food webs, what we're looking at is how energy flows through an ecosystem. So in your textbook is 3-2. And in your notes, you're going to be completing numbers 3 through 11. So take out your note sheet if you don't already have it out, and we're going to start on number 3. We already did that last week. So we're going to, well, I can't go back to it right now. We already did it. Well, all right. So with energy flow, we always start with our producers, and another word or another name for producer is autotrophs. So number 3, another word for producers is autotrophs. There are two main ways of producing food, and one of them you guys have already talked about. One of them you already know. That's photosynthesis. And photosynthesis is used by plants, some algae, bacteria to produce food. And then the other way that I've mentioned in passing is chemosynthesis. We haven't talked about that a whole lot, but chemosynthesis is also a way of producing food. Photosynthesis is going to use light and CO2, so they actually have to be near a light source at all times. And chemosynthesis is going to use chemicals. So these are going to be the ones that they live deep in the ocean. Still number 3. And I'm going to have y'all add chemosynthesis to your notes in a second, but not on this slide. But for number 4, they both are going to make carbohydrates. It's just that with photosynthesis, you're going to use light and CO2 to make glucose and oxygen. With chemosynthesis, because there is no light, they have to use other chemicals, like hydrogen sulfide, which is what they get from the hydrothermal vents deep in the ocean. They're going to use that to make their carbohydrates. So here's a comparison of photosynthesis versus chemosynthesis. Again, photosynthesis uses solar energy. Chemosynthesis uses hydrothermal energy, which is basically just chemicals. And look at the products of both. The products of both have carbohydrates plus oxygen. Carbohydrates being produced. And then with solar energy and photosynthesis, you have that oxygen also being produced. With chemosynthesis, you have sulfuric acid. So we've already talked about photosynthesis. So the only thing I want to point out on this slide is that not just plants do photosynthesis, also algae, and which are protists, and some bacteria. For chemosynthesis, this is the one that I want y'all to just add to your notes. Maybe just add it at the bottom of your page. Chemosynthesis uses inorganic chemicals to make glucose and oxygen. They're going to do that instead of using the sunlight. And the example is always going to be bacteria. So they're going to be located deep in the ocean at hydrothermal vents. And a lot of times they're going to live symbiotically with an organism called a bloodworm. So these things at the bottom right here, they're called bloodworms. And they actually have like a red, it almost looks like blood. And in their blood, they had, well, I guess it is blood. The bacteria are going to live inside the bloodworm, and they're going to collect that hydrogen sulfide from the hydrothermal vent, and they're going to produce the food for the bloodworm. So then the bacteria becomes the producer, the bloodworm becomes the primary consumer, and it's going to consume the foods from the bacteria. All right, everybody got that one? All right, so that finishes up producers. Now let's move on to consumers. Another word for consumer is heterotroph. There are several different types of heterotrophs. The first one is a carnivore. Carnivores are going to eat only meat. Yep. It's sugar, glucose. The next one is omnivores. Omnivores. Your sheet has herbivores next, so skip to omnivores. Omnivores are going to eat both, so they're going to eat meat and plants. And herbivores are only going to eat plants. Yes. So, like humans, humans as a group are considered omnivores because we eat meat and plants. But some people only like to eat only like to eat plants. So those people, even though they're still humans and are capable of eating meat and plants, they choose to be herbivorous or be herbivores because they lead a vegetarian lifestyle. And then the next one, detritivore. Detritivores are also called scavengers. So a simple word for detritivore is a scavenger. They're gonna eat dead stuff. And then obviously you all know about a decomposer. They're gonna break down dead stuff. And really, there's only a few examples of decomposers. We just finished talking about fungi. They're decomposers. And then bacteria are also going to be decomposers. What are some examples of scavengers that you guys know about? Hawks. Not. No, they probably like vultures. Yeah, that's a better example. Yeah. Hawks and owls, they do hunt for their food, but it's usually going to be alive, so they're usually going to be carnivores. Yeah. But vultures are good examples of scavengers. If they eat dead things that they found. I don't know. Are they? Okay. Cool. What's an example of an herbivore that you can find around here? Squirrels, deer, rabbits. Cats are usually carnivores. Yeah. All right. So let's look at the direction of energy flow. So energy is going to flow in one direction, and it's always going to go from producers to consumers. So the start of every food chain is going to be a plant, or an algae, or a bacteria, something that's photosynthetic, something that can make food. And so with a food chain, um, the photosynthetic organism is always going to get its energy from the sun or from the inorganic chemicals. There's the only two places we can get energy from. And from that, it's going to go to some type of producer. So after the sun in a food chain, we are always going to have a producer. There can never be any type of consumer or heterotroph after the sun. It always has to be a producer. Or after the inorganic chemicals, it always has to be a producer coming next. And then after the producers, you got several different types of consumers that could come next, but one of them has to eat or consume the producer. All right, and so when we draw a food chain, we have to draw arrows, and the arrows always point to the organism that is getting the energy. All right, so like the producer gets his energy from the sun, so that's where the arrow points towards the producer. The consumer gets this energy from the producer, so the arrow points towards the consumer. All right, so look at your food chain that you have with the sun, the plant, and the rabbit. See if y'all can draw your arrows in the correct direction. Which way does your arrows go? And then check your answer. So you should have the arrow pointing towards the plant, and then the arrow pointing towards the rabbit. All right, so is this a food chain or a food web? The food chain. How do we know? Well, other than saying it on the board, we know because, all right, they only have, yeah, we only have like one order, all right, one group, one food chain. A food web is going to be a bunch of food chains. It's going to be overlapping food chains. So let's look at your next one. So the arrow points towards the grass. That's going to be our producer in this case. And then one of our food chains can be the sun, the grass, the rabbit, and the hawk or eagle. The other one could be the sun, the grass, the rabbit, and the fox. So see how we have at least 2 food chains in a food web? That's what's going to differentiate between a food chain and a food web. Food webs have more complicated relationships, several food chains. So this one should answer number 8 and 9, y'all. So food web is overlapping or linked food chains for number 9. So looking at the food web that we have on the board, can we place the rabbit after the sun? No, because the rabbit is a consumer. It can't make the energy from the sun. It has to get its energy from the plant. All right, so we can only put producers after the sun. It's going to have to either be a plant, a protus, or a bacteria. All right, what about a mushroom? Can we place a mushroom, which is a decomposer? Can we place that after the sun? No, because the mushroom is a decomposer, which means it's a heterotroph. It's not an autotroph. It's not going to make its own food. All right, and so when we look at a food chain or a food web, we always start with the sun providing the energy for the producer. All right, and then the producer is going to provide the energy for what's called the primary consumer. And in this case, it's the grasshopper. And then we have our secondary consumer. Our secondary consumer is our frog in this case. And then we would have a tertiary consumer. And some of them even go further and have a quaternary consumer, in this case, the snake and the hawk. And then the decomposer could actually be several places on this food chain or on a food web. The decomposer could actually be after the producer because it can break down the grass. It can be after the grasshopper as a secondary consumer because it can break down the grasshoppers. It can be a tertiary consumer because it could break down a dead frog. It could be a quaternary consumer because it can break down the dead snake. All right, so it can actually go anywhere after the producer. All right, it cannot be a producer though. So decomposers are funny. They can actually change levels. A lot of organisms can change levels. What about humans? Which of these levels could we be? Think about what we eat. So if we eat plants, what level would we be? We would be primary. Good. If we eat, let's say I just had a hamburger for dinner last night. The cow ate the grass. I'm eating the cow. So that makes me a what? A secondary. Yes. So humans can change levels as well. So consumers are all heterotrophs. They cannot be placed after the sun on a food chain. That's number 10. And then number 11, decomposers are also heterotrophs. They cannot be placed after the sun. Only autotrophs can be placed after the sun on a food chain or food web. All right. So that's actually where we're going to stop with notes today. I'll get to energy pyramids and stuff tomorrow, which are also a way of showing relationships. And then today you guys can work on the food chain worksheet.